So now that we've gone over the ANSYS interface, let's go ahead and start the project. So the first thing we're going to do is either double-click on the static structural analysis or hold and drag it onto the project schematic and then let go. This will basically add the analysis system to the schematic. Now ANSYS will automatically ask you to name this analysis, so we're going to go ahead and type lifting lug, and then we're going to hit enter. Now as you can see, the workflow is from top to bottom, and as each stage is complete, the icon on the right hand side will change. Now these icons are called cell states, so let me just give you a quick overview of each one of these cell states. So the first one is the hollow question mark called unfulfilled. This means that the required upstream data doesn't exist. So in this case, cell 4 is not updated and therefore doesn't exist, so cell 5 is unfulfilled. The second one is the green arrows called refresh required. This means that the upstream data has changed since the last refresh or update, so you may need to update this cell. The third one is the solid question mark, which means attention required. So it means all of the cell's inputs are current, however you must take some kind of corrective action in order to proceed. The fourth one, which is the yellow lightning bolt, means an update is required. So you can go ahead and double click on the cell and click on update in order to update the cell. The green check mark means up to date, so this cell is completely up to date. And the green check mark with the yellow arrow means that the input changes are pending, so the cell is locally up to date but may change when next updated as a result of changes made to the upstream cells. And here are some other cell states which I will not be covering right now, but you can go ahead and find them in the help menu. So coming back to the project schematic, we can actually build the same analysis system using the component systems instead as an alternative workflow. So we can go ahead and individually create this system by, let's say, selecting the geometry and dragging it into the project schematic, and then going ahead and then dragging the mechanical model on top of the geometry in order to link it together to create the mechanical model. And then finally we can go ahead and drop a static structural on cell number 4 to link all that together into the static structural. So this is basically another way of creating the same workflow. However, in this case you can create individual blocks. So let's say we can start with the geometry and then create our mesh, but then let's say make a thermal analysis instead, so we can go ahead and drop that there. And then now you can see, using the same geometry, we can run the static structural and thermal models side by side. So the square connector shows that the geometry created in this previous cell here is being shared with this cell over here. So any modifications to this one will be automatically updated in this cell. Now if we add, let's say, a steady state thermal analysis and we drag it onto our schematic over here, and let's say we ran a static structural analysis and we want to use the results of this structural analysis as an input to our thermal state model, well, we can go ahead and click on, let's say, the solution and drag it into cell number 4, the model, and this will create a round connector. And the round connector means that the results of this analysis is being transferred as an input condition for the next analysis. So should you ever want to rename an analysis system, you can go ahead and click on the small down arrow on top of each system. And then this will bring up a small pop-up menu, and you can go ahead and click on the rename. And then here you can type in renamed part. And there you have it. And this menu actually also has a bunch of other features that you can do, such as update the analysis, create a copy of it, replace it with a different system, clear its generated data, delete it, see the properties, and even add a note. So we're just going to go ahead and now quickly delete all of these systems and click on OK when the pop-up menu comes. So we're going to delete the steady state thermal, we're going to delete the static structural, delete the mechanical model, and then finally we're going to delete the geometry. So now that all the components are deleted, let's go ahead and save the project. So we're going to go ahead and click on the File menu and click on the Save As button. Once here, we're just going to call this Lifting Lug Tutorial. And then click on the Save button right here. Now that our project is saved, I want to just go into more detail about the View Files tab. So let's click on the View and then click on Files to show the files. So this will enable you to identify the individual files on your disk for each stage of the project. The resulting table will cross-reference the directory and file names with the project cells. So as you can see, the Workbench project comprises of many files and directories on the disk. As mentioned before, if you need to archive the project or bundle it to send, use the Archive tool, which generates a single zip of the entire project. So let's go ahead and do that now and click on Save. When archiving, you can either choose whether to include the computed results file or not. Omitting these results file can greatly reduce the file size of the archive, which could make it small enough to even send over email. So let's go ahead and uncheck the results option and click on Archive. Now, let's go ahead and restore this archive. So let's go into the File menu, click on Restore Archive, and now we have our archived file here, which is saved as a WPBZ file. Click on the archive and then click on Open. Once you open it, ANSYS will automatically ask you where to save this file. So we're going to go ahead and save it in the same directory and click on Save. And we're going to go ahead and overwrite the existing project. So that's how you open up an archived file.